Figure P2-6 then has the same techniques. We're going to be watching for relations. We have a couple of those interior-exterior angles that we're going to have to contend with. We're in millimeters, and thickness will end up to be 12. Again, with the rounding errors, let's see, we're solving for E, F, and G. So E, F, and G at the vertex of F. And the length that we're looking for is F to G. So let's go with that that midpoint line again. I'm still trying to get a little more used to it. So front plane sketch. We'll go into the midpoint. We'll set it on the origin, and that'll be our A to B line. We're going to hit OK, uncheck the midpoint, and then that will put us into our sequence. Alright, so again, watching out for those inference lines, and if you get the little yellow boxes that are going to apply perpendicularities, we're going to move just slightly off of those lines. Alright, so at any point that you click on the checkbox, even though midpoint line over here is not checked, the symbol shows me that I'm in midpoint. I'm going to get that back. Alright, so I'm in midpoint, and to correct, I'm going to identify, come over to the relation, delete the midpoint, but I still have that point location that it created for me, so I'm just going to window pick and delete that out, drag it back. Sometimes it seems like that would be about as easy just to go ahead and delete it and put it back in, but knowing how to correct some of these, there are times where we want to preserve geometry, so being able to make those adjustments is handy. Alright, so I'm going to go ahead and sketch this one all the way around, looking for those relations. And so a disadvantage of going all the way around is that it's a little more complicated, but I'm in that mindset to look for those relations as I'm dragging and dropping the lines, so that is the plus. Alright, so we'll start with our angle, 119.88. Let's see, A to B is 130 millimeters, and then B to C, and we already have that movement, so let's get back to our linear. B to C, 28.1. Alright, so since that was an interesting move, I'm going to drag it a little closer to where it's supposed to be, and maybe try to get the 119 out of the way. Alright, so again, the exterior angle, if I go to drag to that 104.58, I'm going to do the interior angle, and the interior angle 100.81. Alright, so if we needed to, we can drag off parallel. I'm not sure which one it's trying to be parallel to. It picked up a parallel somewhere. So orange is in the lower right. It's trying to be parallel to that one. So anything that we do at this point is probably going to find something to infer to. So almost everywhere I drag is finding a relation to infer. So I'm going to be collinear and collinear, and actually both of those should have been construction lines. So let's just shift or control select both of those and switch over to construction geometry, and then we'll just go into the proof real quick of our opposite angles being in the 100.81. Alright, so that angle is still capable of moving, just kind of curious why it was blue. And we need another dimension from C to D then is 40.6, and D to E is 111, and then we have a 64.2 as the interior angle, Alright, so these are coming together okay. We'll try and work this all the way around then. Alright, so I'm making sure that I'm staying on that linear. E to F, 133.9. And then that's the angle that we're trying to find, and that's the distance that we're trying to find. So I have to start, either come down this way or go back to the lower left. Let's just kind of keep going here, see how that works out. 99.55 for our angle. H to G is 114. 48.95, and then H to J is 70.6, and then J to A is 56.7. Alright, so when I put in the last couple of angles here, we'll put in angle at vertex J, 85.38, and that's a little cluttered, so let's drag that out and verify it real quick. And then that went fully defined. So let's see what this angle says it is while it's being driven. Make this dimension driven. 66.03, and we're actually on their dimension 66.05. So that's a little bit of an issue. Let's go look and see that we didn't pick up extra parallels, perpendiculars. Alright, so having gone through this, one of our strategies is to just highlight each of the lines and look. But if I wanted to look at the whole group, everything in this sketch, we have horizontal, couple collinears, the midpoint, all of those look like distance relations, angle relations. I don't see any parallels and perpendiculars in that mix. So since this is 0.02, I guess that I could say that's within my margin of error. I would like to know why, we're getting up to the stack up. But let's see what we come up with for our angle, and this is also going to be a driven dimension, 62.1. And then the length, I get 34.04. So if you get into that that range, if this is critical, we would chase it a little bit more and find that angle. The other one, P2-5, still annoying me a little bit, that I need to find out why those angles are what relation stacked up. So in this case, since I came all the way around and got back over here and had the issue, it's almost one of those I would have been better off starting at this angle, working back to the center, and picking up the geometry that way. Alright, so I'm still going to call this one good. If you get something different, or as long as you don't get something extremely different, if we're in a decent range of error, maybe 1 or 2 degrees, I think would still be acceptable on this mess. So we extended out the 12 millimeters and we're ready to save it.